Hi, everybody. Today I want to share with you part one of our chemical equilibrium notes. So you have these notes available to you on Brightspace, but I just want to go through them with you quick and then show you how to calculate equilibrium constant. So first thing first, what is equilibrium? This is a nice fancy definition, but basically equilibrium means that chemical reactions are happening both in the forward direction and the reverse direction, and those are happening simultaneously. So we've written chemical reactions at equilibrium, and we represent them with an arrow that goes both directions. So it's like a double-sided arrow to show that the reactants are turning into products, and at the same time, those products over there are breaking back down into the reactants. So it's just when the forward reaction and the back reverse reaction are happening simultaneously. This doesn't happen with every reaction, and the way we can tell the amount of reactants or products that are there is we can calculate the equilibrium constant, which is represented by a capital letter K. So if we calculate equilibrium constant and it's bigger than 1 or a lot bigger than 1, that's going to tell us when that reaction happens, it's going to contain mostly products, meaning that that forward reaction is happening at a faster rate than the reverse reaction can. If we have the opposite of that, where K is small, a lot smaller than 1, that means that that reverse reaction is happening or proceeding quicker, faster than the reactants can break down and make new products. And then we have where K is equal to 1. And this is rare, where we have equilibrium where the reactants are turning into products, the products are turning back into the reactants, and that's happening at the same time, and there's equal numbers of products and reactants. So when we calculate K, it tells us a little bit about what kind of equilibrium we're at and what kind of reaction we have. So we need to know how to calculate K, which is the second part of what we're going to talk about today. And to know the value of K, you need to know two things. So you need to know the chemical reaction, the formula for the chemical reaction, the chemical equation, and you need to know what the concentration of the substances are. So the word concentration should refresh your memory that you need molarity of the substance. And when you know those things, you can calculate the equilibrium constant. So this one on here, this example problem, is when you have nitrogen gas, nitrogen gas and oxygen gas going to make nitrogen monoxide. And there's 1 mole of nitrogen, 1 mole of oxygen to create 2 moles of our nitrogen or nitrogen monoxide. And over here, I just kind of generically added numbers or concentrations of these values just to make our math a little bit easier. To solve for K, we are going to use a formula where our products are going to be on the top and our reactants are going to be on the bottom. And we're going to plug in our molarity of the substances based on what their concentration is. So this one looks where we would have this NO on the top. The concentration of NO would be the top of our fraction. And the bottom of our fraction would be the nitrogen and the oxygen, the concentration of those two things multiplied together. If I have more than one product, both of those things would be in the numerator. And if I had only one reactant, I would only put one thing down on the bottom. The other thing I want to take into account is the number of moles that are present there. So as you might notice that there's a little superscript 2 there. That is because I have 2 moles of NO. So depending on what this number is out in front, I'm going to raise that concentration to that power. So since I have a 2 here, I'm going to take the concentration of NO and raise it to the second power. If I had a 5 there, I would raise it to the 5th power. depending on however many moles there are. And down on the bottom on my reactant side, I don't have any numbers out in front, so I just have one. I don't need to raise any of those to a power. So I'm going to plug all these concentrations in, raise them to their appropriate powers, and then just type them in the calculator. So for this one, I'm going to take 0.5 because that's the concentration of NO, square it, and then divide it by the concentration of nitrogen times the concentration of oxygen, which gives me a K value of 0.125, which is a small K value, which means that this reaction is going to proceed in the reverse reaction where I have mainly reactants in my equation. So I'm going to pause the video for 1 second, and I'm going to switch over to the practice problems, and hopefully I can do one more with you over there. So I'm going to pause, and I'll be right back. All right, I'm back, and I switched my screen, so now you guys get to look at that nice light up there on my ceiling instead of me, but otherwise I can't draw on my computer, so I'm still here. I'm just, I don't know, enjoy the view. So you have this equilibrium constant practice problems. I think there's 3 on here. Yeah, there's 3. I'm going to do number 2 with you just to show you another example. So I have a pen. I have a pen. Awesome. Okay, so looking at this equation, I have hydrogen gas, chlorine gas to make hydrochloric acid. It's balanced. I have 1 mole of each of my reactants and then 2 moles of my product. So when I'm solving for K, I'm going to need the concentration of my products, HCl. They go on top. The concentrations of my reactants would go on the bottom. And then if I have more than 1 mole of a substance, I need to raise it to that power. Sorry, this 2 should be in here. My bad. So the only superscript or coefficient I have is that 2. So my top number is going to need to be squared. So now I just kind of plug in my numbers where they go. So on the top, I'm going to get 0.0625 squared divided by 0.0045 multiplied by 0045. I'm going to plug that into the calculator, and that is going to give me my value of K. And from there, I can tell, do I have a lot of products? Do I have a lot of reactants? Or are they equally happening at the same time? This worksheet has a QR code. So when you are done with, when you are done, my dog just made a really strange noise, sorry. When you're done with number one just wants you to say how you would solve it. And then number 3 goes a little bit deeper. But when you're there, you can check your work and see how you did. Email me with any questions you have. And we're just going to stop there today with equilibrium constant. So have a good one, everybody. Talk to you later.